In this episode, we will continue working on our real-time video call application. And just to show the progress, right now, if I click right here, the online user, I'll be able to emit a call to this other user right here. And what I want us to do is to handle this answering a call, okay, in this particular episode. And things might start getting confusing as we move on into the code. And if in any case things start to get confusing, I covered this particular diagram in the last episode, which explains everything that is going on and will be going on in our application. And if you get lost, always come to this diagram or to the last episode, and you will be able to understand, how things are going. And right now, what I want us to do is to create a peer and emit an offer to our server, and then the server will send that offer to this other peer. Because so far we can make a call which gets to the server submits that call notification to this peer, and that is why we are seeing this call notification. And then once we get this, we can either hang up or answer. If we hang up, we just stop everything. If we answer, I want us now to proceed to the next step. We will create a peer and we will emit an offer. So let's get started. In the code, I am in call notification. We had this button for answering a call, which is this one right here. And this is where we will begin everything. And we will have an on-click event. So I'll say on-click. We will have an arrow function that will pass, and we will handle join call. This handle join call will receive the ongoing call. We receive that ongoing call. So this handle join call function, we will create it in our use socket, and then we will bring it in right here. So let's do that. I'll come right here and I'll go to the context and then socket context. In socket context, just scroll up to where we have some use effects right here, and we'll do it just at the top here. Okay, so I tap there, and here we'll create that function. I'll say const handle join call will be equal to, we'll make use of the use callback hook to optimize this particular function. I invoke it. This use callback accepts a function right here, and at the end we'll have some dependency arrays. Here the dependency array will be the socket, and we'll be having current socket user as the dependency array. Right here we will be receiving an ongoing call, and this will be of type ongoing call. And in here is where we will do stuff to handle the joining of a call. So join call. So up to that point, we have just created this particular function. We will export it, or we will add it to the value of our context. So to add it to the value, first of all, we come at the very top where we have iSocket context, and we will add it to these types. I'll have handle join call full colon. This will receive an ongoing call of type ongoing call. So this is with a small o, and then this is with a capital O. This is the type. This is what we will be receiving. We will be able to return void. So we return nothing. Very nice. Now, once we do this, you'll see that our value here complains because it expects us to pass our handle join call. So we pass handle join call right there, and they save. So now if I come back to call notification component, we will be able to receive our handle join call right here. So handle join call, just like that. And as you can see, the error disappears. Now we can call that function here. We pass ongoing call here, and just like that, we have now our ongoing call right here in our function. If I say console.log of ongoing call, we'll get our ongoing call. So I save, I call. Here we are having the video going on and so on. And here we click on this button to join a call. So let's come to the console and see if we get our ongoing call. So I click on this one. Okay. Yes, I click and we get this ongoing call. We have is ringing, we have participants, the person who called, the person who received. So we are getting that. So far, so good. Now, once we answer a call, the first thing that we will do is to set the is ringing state to false. And that will just hide the call notification UI. Set ongoing call. Here I'll have a previous, and right here, if we have the previous, we must return something. So we will return, we spread previous, and we will edit is ringing. So previous is the previous state, and we update the is ringing state to false. Okay, now this is if we have that previous state. If we don't have the previous state, we'll just return. So I'll say else here, or not even else, just at the bottom here, you can just say return previous. The second thing is to get our stream, our local stream. Okay, and for this other user, you can see we have this stream, video stream going on. But for this one, we don't have that stream. So we get the stream for this user now, okay? And we had created a function for getting a stream. So we'll just call that function and we make use of it. So after setting that, we'll come here and I'll say const stream. Stream will be equal to, we await, and we'll say get media stream, and we invoke that. And you know, in this particular function, we were setting that local stream to the state. So this get media stream here, we were also getting the stream and setting it to our state. So we'll get the local stream going for these other users, so they'll be able to see their own video. But for us to send that stream to the other user so that they can see you, we'll now create a peer, and that peer will contain the stream. So right here, this will set your local stream, but we'll make use of this stream to create a peer. So await complaints, but that is not a problem because here we just need to say async. First of all, if we don't have a stream, we'll not continue with joining the call. You might not be having a stream, either you don't have the camera connected, or the camera is in use by another application, or you have disabled the camera, or for any other reason, we might not get the stream going. So here you say, if we don't have this stream, we'll just immediately return. So we will return, and we can console log right here for us to see that this call didn't go on because we didn't have a stream. So could not get stream. You can specify the function in handle join call. If the stream is there, we'll go ahead and we will create a peer. At the top here, I'll create a function that will help us to create a peer. I'll say const create peer will be equal to use callback. So to optimize this function, we make use of this use callback. We pass an arrow function here, and here we'll have some dependency array. Now for the dependency array, if ongoing call changes is when we'll be able to call this create peer again. So ongoing call, and that means that this function will not be created on every re-render. Only when ongoing call changes, the function will be created, okay? And that saves on memory and so on, makes our app much faster. The first thing that we'll receive is the stream that we created, and this will be of type media stream initiator. Now, initiator is like the person who is creating the offer and emitting the offer. And then the other person will be answering the offer. So the person who created the offer is the initiator. We'll have this as Boolean. So for these to work, we'll make use of a library called simple peer. So we need to install that particular library. npm I of simple hyphen peer, and I hit enter. So as this installs, I'll come back to this create peer here, and we will be needing to configure some ICE servers. And the iServers include the turn server and the stand server, like I showed you in this particular diagram. We are at this step. We want to create a peer, and when creating a peer, we will configure these stand and turn server. This is what we are calling the iServers, and they will support this peer-to-peer communication. So right here, I'll just say const iServers, and we have some free iServers that are available in Google, and we'll make use of those. So here I'll say these will be of type RTC iServer, and these will be an array. So we set this to be equal to an array, and in here we'll pass an object and we'll configure the URLs to those servers, and you can copy these URLs exactly like I will do. So URL will be an array, and we say here stan stan.l.google.com :19,302. So stan.l.google.com :19,302. So there are several of them with a similar URL. You can duplicate this 4 times, and then you'll have stan. These now will be stan1, this will be stan2, this will be stan3. So we have stan1, stan2, stan3. So those are our iServers, and we'll come now down here and we will create a peer. This completed installing that library, the simple peer library, and we will say right here const peer will be equal to new peer. We use this class. This peer right here will come from that simple peer library, but it's already complaining. I'll click at the end and try to import. Okay, it doesn't give me the suggestion to import, so let's import it manually. And I'll say import, and I'll say peer, we'll say from simple peer. So what we need to do is to run npmi, and we save the types as dev dependencies. So I'll copy that and I'll install the types. And then down here now at create peer, we'll pass some options here. The first one is the stream that we brought in right here. So we say stream, comma. The other one is the initiator that we also bringing right here. Trickle to be true. Trickle here means that during the peer-to-peer communication, the iServers will be shared as they get discovered. Okay, it will not wait for all of them to get discovered so that it start sharing the data and so on. Config our iServers. I pass our iServers right here, which we set up right here. So we pass them right there, and just by doing that, we have created this particular peer. The peer will be able to listen to some events. Okay, the first one is the stream event. So peer.on, and here I'll say on stream, and this stream event is when we receive the video data, the audio data from the other person who like answers our offer. Remember here we will emit an offer. When the other person answers the offer, they'll be able to send us the video, the audio, and so on. So we'll get that stream right here as a callback. So stream, and here this is an arrow function, and what we want to do is to add this data to our state. And once we add this stream to the state, we'll be able to show that video for the other person on our UI. So now we'll be having 2 videos, our local stream and this stream that will come from the other person. Okay, I hope that makes sense. So here we'll be having some piece of state, and I'll say const peer and set peer. This will be equal to use state, and I'll invoke that. I'll say null, and then right here I'll have this as a type of peer data, which we haven't defined yet. or null. Now I think we had a file with the types. We had this file. So we go to that ongoing call, and down here we will define the type for the peer data, the type for our peer. Export type peer data will be equal to, and right here we'll have a peer connection. We'll set that to be of type peer.instance. I think we need to bring in this peer. Okay, let's do it manually. Again, it doesn't auto import. We'll say import peer from our simple peer. So this peer connection will be of type peer.instance. The stream will be of type media stream, or it will be undefined. Okay, very nice. We'll have participant user, and this will be of type socket user. Okay, we do that, then we come here to our socket context and we bring in our peer data, which we just created from our types. So our peer will be of type peer data. Peer data will have peer connection, stream, and participant user. So now that we have this state, we'll come now here, and once we get a stream, what we want to do is to update this stream right here, which will be part of our peer. We'll just say set peer, we invoke it, and we will pass an arrow function like this, and here we will receive the previous peer. And now inside here we will say if we have the previous peer, we will update that peer. What we will do, we will return, and what we will return here is our previous peer, but now we pass the stream. If we don't have the previous peer, we will just return right here. So we will return our previous peer just like that without adding a string. And we can add this set peer at our list of dependencies. So I'll say set peer. Okay, so when we receive the stream or the video, the audio from the other user, we will add that to our state here, and then we'll be able to show that on our UI. So this is the first event that we can listen to. So here I'll say peer dot error, and here we'll just say console dot error. And right here now we'll also have peer dot on and close. For example, if the other person maybe closes their window and they are no longer, online. And what we will do is to handle hang up. So we don't have this function yet, and we will not cover it in this particular video, but we'll just create it. Okay, and here we'll just create that function. Const hang up will be equal to an arrow function. Maybe we'll make use of use callback as well, and we'll have an arrow function there that will handle our hang up. Okay, so dependency array, this will receive an object that will have some stuff in there, and we'll cover that in the next video. So handle hang up, if they happen to close, they happen to hang up, they happen to close the window, we will call this hang up, which will clear everything and will no longer be on call. Very nice. So up to this point we have created a peer, we have recents to these events which are very important. Right here I'll just say const, and we'll have RTC peer connection of type RTC peer connection, this one, and then we'll say this is equal to, and we'll say in here peer as any, to bypass any TypeScript issues, and then right here I'll say dot PC. So this PC holds the connection, so we get that connection right there. And then now right here I can say RTC peer connection, then dot on ice state change. This is the change of the ice servers, and we'll set that to be equal to, here we'll have a function and we'll do something in here. If we have a change, we'll get this async function going on. And inside this particular function, what we will do, we'll say if the RTC peer connection dot ice connection state is equal to the disconnected state, or if the RTC peer connection dot ice connection state is equal to failed, so it failed to connect or it disconnected from the ice servers, then we'll go ahead and we hang up the call. So we'll say handle hang up, just like that, and later on we'll implement this handle hang up further so that we complete whatever we are passing right here and right here. So for now we'll leave it at that. And with this we have been able to create a peer. And one thing that we are not doing is that we should return that peer from this particular function. So we have created it, we are listening to several events. If we have a stream, we add it to peer in our state. If we have some errors or we close and so on, we hang up. And then at the bottom, after this now, we will return that peer, okay? Return peer. And I save. Now, remember, we were at handle join call, and after this stream is where we want to create the peer. So we have created that function, but we are not calling it yet, so we should call it. We will say const, and we will say new peer will be equal to create peer, and we will invoke it. And why are we getting an error? Because we expect some arguments. Okay, in here we will have the stream. We'll also have true as the initiator. Set peer, and we will pass this object. We will say peer connection is new peer, and then we will say participant user is our ongoing call dot participants dot caller. We will set stream as undefined, because we don't have the stream for the other user right here, but that stream will be updated whenever we get this stream event, and then it will update that stream for the other user, and we will get it at our peer. Note that we have this stream. This is for the local stream, the person who is like currently running this function. And then when we get the other stream, that will come through our peer, and we will resend to that event right here. And then we will set that to our state, and we will get the updated state. So here we set the state, and this will be updated whenever we get that event. When peer is ready, we will get a signal, and we will resend to that event. So we'll say new peer dot on signal. Here we will pass an arrow function, which we can do stuff with it, a callback function, and this can be async. We will receive data, and that will be the signal data. So of type signal data. This signal data type will come from our simple peer library, signal data, and the signal data is like the SDP data and so on. So basically, when the peer is ready, we'll be able to have this event, we resend to it, and then we will get that data, the signal data. And right here we will perform a check. If the socket is ready, our socket IO, if socket is there, what we will do, we will emit an offer now to the person who called us. So we'll emit a WebRTC offer. So here I'll say console.log, and here we will be emitting an offer, or you can just comment, okay? Emit offer. So right here we'll have now socket.emit, and we will emit WebRTC signal, WebRTC signal to the server, and then the socket server will emit the data that we pass here to the person who called, okay? And then the person who called will respond with an answer which will contain his SDP data and the stream and so on. And then once it comes back to us, we'll be able to complete the peer-to-peer connection and the video call will start flowing on. So again, if you get confused, go back to the last episode where we had that diagram. So here we are emitting the offer and we pass the data and we'll have SDPS data, and that data is this one here, which we get from our peer signal there. And here we'll have our ongoing call right here. For more information about the call, and we'll say is caller, here will be false. So the person who is emitting this offer is not the person who called, it's the person who received the call, and then they'll emit a WebRTC offer. So that is our handle join call function, and this episode is long enough, and in the next episode we will see how we can complete this peer-to-peer connection.